Okay, good afternoon, everyone. Everyone enjoy your holiday, right? Enjoy your Hari Raya holiday, right? Okay, so this week we come tonight actually lah. Tonight we come back for our uni lesson for this week. Okay, right. Our last lesson was we did some revisions on chapter 3, right? Chapter 3. Chapter 3 is a new chapter. And then most of you you did not study chapter 3 properly in a proper way. That is the reason why I want to do revision for you. Okay. I want you to look at this paper first. Okay. Can you all hear me or not? You can hear me. Can you show your thumb? Can hear me or not? Then, okay, thank you. Okay. Sorry, I forget to click share. Every time I forget this step. Two more people. I let them come in first. Okay. This paper another one come in. Okay, wait. I want you to look at the formula first. Okay, all the formula you have learned in your chapter 3. Sorry because now what suddenly got 7 people waiting. Okay, hold on. Okay, here the last page here. Okay. Class, when you look at here, the whole chapter 3, right? You are going to focus to all these important formulae only and all. You all remember all these formulae or not? Your whole chapter 3, something wrong or why they all cannot come in? Live problem. So them outside. Okay. Start from here Hold on Sorry because I really can't focus, because there's still student outside there. They cannot come in. I don't know why. I don't know what is the reason. Win Lim and Zhong Chaoyi, I clicked for them many times already, but they still cannot come in. Okay. The first formula, so this one is to find the gravitational force between two bodies, okay? Remember this formula, The second formula is to find gravitational acceleration, to find the gravity, okay? This one also you have learned last week, okay? Use it many, many times. To find the gravitational acceleration, Gm over R squared, okay? And third, this formula, I think last lesson we did not use it. This one is to find centripetal force, okay? Centripetal force means when some object is turning, right? When the object is turning, orbiting another object, there will be a centripetal force to keep the object orbit at the same circle lah. That force is called centripetal force. Okay. Next is centripetal acceleration. This is an acceleration. This one and this are related. This one is to find the centripetal force. This one is to find the centripetal acceleration. E squared over R. Okay, another one is to find the speed, orbital speed, to find the speed, right? Speed of object in an orbit. This is the normal formula to find the speed. You take one circle, right? The circumference is 2 pi r. So 2 pi r divided by the period. You know why? They still cannot come in, they all. The house line problem, I think, right? The house line is too busy. Okay, and to find the mass of Earth or the Sun, if you're asked to find the mass, but this question seldom ask one, seldom ask you to find the mass one. Okay, if they ask you to find the mass of the planet, to find the mass of the Sun, Earth, right? This is a formula: 4 pi squared r cubed over g, the gravitational constant, and the period t, square of period, 4 pi squared r cubed over gt squared. Okay, and this value also remember, right? I told you, gravitational constant value. This one very often we use one, the big G value, 6.67 10 to the power -7 Newton per meter square per kilogram. Newton meter square per kilogram square. And the gravitational acceleration for Earth, this value you know already, like 9.81, right? Okay. Right. Beside this, you also learn this, Kepler's third law formula. Okay. Okay. This formula actually I prefer you to follow this T1 square, right, over R1 cube, right, equal E2, right, square over R cube. This one is 2, okay? Put like this, 1 here, 2 here, 2 here. So this one you can bring up, this one bring down, it's the same. So this formula is very often we use one. Okay? T square over R cube equal T square over R cube. This is 1, this is 2. Why got 1 and 2? Because different situation. Maybe this is for planet X, this is for planet Y, so it's different situation. Okay? Right, another formula is orbital speed. This formula. To find the speed, how fast the satellite need to orbit around the Earth. Orbital speed, this is very important, The satellite must orbit in a certain speed, right? Then only it can maintain in the same position one or keep rotating. You must maintain certain speed. So this speed is called orbital speed. So it's square root gm over r. Okay. Another formula is gravitational potential energy. Negative to remember. This is the only formula. Only formula for energy which is negative one. This one is gravitational potential energy. Okay. Because why negative? Because it's opposite direction. Because when you see the rocket flying up to the space, right? Rocket flying up. When the rocket moving up, you have kinetic energy. Okay. But the higher you go, then you have potential energy, right? Correct not? But the potential energy is coming down to the Earth. So it's negative. So you put negative. Okay, this is gravitational potential energy. This is kinetic energy. Okay, this kinetic energy is an object leaving the Earth, going away. Decide positive. When you're going away, then only you gain the potential energy in opposite direction. Okay, so this energy, kinetic energy plus the potential energy will become 0. Okay, they balance up, so become 0. And last formula is escape velocity. Square root 2 gm over r. Escape velocity is also very important one, okay? This is a minimum speed required for an object to escape from the gravitational pulling force. You want to go away from the Earth, right? Want to go away, right? You must have minimum speed, that escape velocity lah. So use this formula lah. Okay. All right. Now we continue answer. Last week I think we stopped at question number 50. Correct not? Okay. Now we move on to another one. Okay, now is question 51. I think. Wait. Hold on. We stop at this question, I suppose, right? Question 50. Correct. You stop it here. Okay. Now we look at question 51. Okay, question 51. You must have your paper with you, question 51. Okay. Read the question. Earth has orbital period 365 days and means distance from the sun. This is R. This is a T. Period is T. Distance is R. Then definitely Kepler's law lah. The planet Pluto's mean distance from the sun is this. This one is for another planet, the distance R. By using Kepler third law, calculate the orbital period. Okay, very simple. Okay, so just check your answer now. I believe most of you already answered the question. Okay, another two more coming in. Hashini in already. Why now come in again? She left just now. Okay, this one is for the Earth, right? Period 365 days square. And the distance, the radius is a distance 1.49, 10 power 8 is here, cube. Then this is a Pluto, period, you don't know. But the distance is changed to 5.89610 to the power 9. Okay, here both sides are in kilometer. This one kilometer, this one also kilometer, so I don't need to change to meter because kilometer here can be cancelled off. So I don't change to meter here so cancel off Okay, use your calculator, calculate carefully, right? You use your calculator, you press this number, then multiply here, divide this, so you get this answer. Okay, 90399.8 days. This one straight away you get the answer in days and all, because this one is given days already, not second days. So you get the answer in days straight away. Okay. Fong Chao Yi, I don't know what happened to him. No, he cannot come in now. Yeah. Okay, question 52. Read the question. Planet Venus orbit the Sun with a mean orbital radius. This is a R. The mass of the Sun, this is a mass, M. By using Newton's versions of Kepler's third law, calculate the orbital period. Okay, to find the orbital period based on the mass, right? This is a formula. Use this formula to calculate. Okay. Remember this formula or not? This one is also Kepler's formula, you know, but if given the mass, you have to use this formula lah. T square, also you can see T square R cube here, right? But here is 4 pi square Gm, okay? Because you have to use a mass. So plug in everything there. R is this distance now, 1.073 10 to the power 11 cube. Okay. Constant gravitational G, this value. And this is the mass of the sun, okay? No, M. So use your calculator, calculate carefully, you get this answer. And this answer is in second, okay? In second, when you calculate anything, period, unless it's not given in the years, you put in all the number inside, right? So you will get in second. Then second change to day, change to day. The other day I told you how to change already, right? How to change from second change to day? How to do it? How to change? You all remember or not? Second change to day. 1 hour 60 minutes. 1 minute 3,600 seconds, right? So you divide by 3,600, then divide again by 24. Then you get days lah. Divide 2 times lah. Okay. Divide 3,600 and divide again 24, you get the answer in days, okay? 221.7 days. Got it or not? Pritibha, understand the answer or not? Pritibha, understand? Okay, thank you, Pritibha.
From Shang to all, thank you.
Who's laughing there, Zhang Chaoyi, you come in already or not, Zhang Chaoyi? Okay, now in already, Zhang Chaoyi. Zhang Chaoyi, can you hear me? Okay, next question, question 53. Calculate the acceleration of Earth gravity at the distance of 350 kilometers above the Earth. Okay, this distance is not from the center of the Earth, is above the Earth. You see the distance from the surface of the Earth. And gravitational constant, this value, mass of the Earth, radius are all given. Okay, once again, you're asked to find the gravitational acceleration, right? So this is a formula, right? Big G mass over square of the R. Okay. Gravitational constant value is here. Okay, the mass, take this value lah, mass of the Earth. And this distance now you must add the radius, because the total distance from the center of the Earth line must count the radius plus this distance. Okay. 350 kilometers, you change to meter now, so you add 30. Okay. This is a distance above the surface of Earth plus the radius of the Earth. So this is a total distance now. Total distance from the center of the Earth to the object lah. Okay, so you square the whole thing, use a calculator, do it carefully, you get the answer. 8.82 meter per second square. Okay, this one at 30 because it's kilometer change to meter. This one is already given in meter, so I don't change, right? It's already meter. Okay, right? So just a matter of memorizing the formula in this chapter, you know. There are many formulae in this chapter lah. This chapter is just like a mathematics, you know, a lot of things to memorize. Okay. Okay, 54 now. Okay, read the question. A typical white dwarf star means a planet lah. This is a name of the planet. Okay, white dwarf star, which is now in last stages of its evolution. It's going to die already lah. Okay, as the mass of our sun. Okay, the mass are same as our sun. You know, very big one. No. What is the radius of this star if the acceleration due to gravity on the surface of this star is 4.410 to the power 7? This is the gravity, okay? Right, we are using the same formula, this formula, okay? So you put it here. And now you see how we use the formula. The gravitational acceleration given already 4.410 power 7 is given here, okay? And this is constant gravitational constant, this value put in. And this is a mass, the mass is given, right? 1.9910 power 30, because it's saying the star, the mass are same as the sun, is given same as the sun, okay? So you can use the sun's mass, okay? You are supposed to find the R, find the radius, find the distance. They say, what is the radius of, find the radius, find the R, okay? So find this R. So what you need to do is bring the R square up here and this number bring down. So exchange now, this R square go up, this number go down. So use of calculator, press very careful, so you get this answer. Okay, you get this, then finally you square root, then you get this. Okay, this is the final answer. Okay, copy down the answer now, please understand. Same formula, we are using the same formula like just now the one, this formula. Okay. This formula, same, using the same formula, but 5 different things now. Okay, so in this chapter, one thing is you memorize all the important formulae is important. Another thing is you must very good in using the calculator. You must be very smart, you know, use your calculator. So you must practice practice using your calculator. Okay. It's very important. You must know how to use your calculator to get the answer, you know, for this chapter lah. Okay. Kian Leong, understand? Kian Leong, understand? Let me Chong, do you understand?
Understand, sir.
Understand. Okay. Thank you. Sima, understand? Simon, Sima. Sima, do you understand? No sound already. Okay, question 55.
Understand, sir.
Understand, Okay, thank you.
Yes, sir.
All right, thank you. Okay, next question. 55. Okay. Study the question first. Determine the linear speed, mean find the speed of the satellite moving in a circular orbit about the Earth at the height of this from the Earth's surface. This one, this distance 3,200 kilometers is from the surface, not from the center of the Earth. You know, any calculation involving distance, the distance must count from the center of the Earth. Remember, not only this, you know, you must add the radius. The radius is this, so this one add this is total distance. Okay, so to find the linear speed means is to find the orbital speed What is the speed of the satellite to orbit, right? Okay, so the formula, this one, okay? V equal to square root gm over r, okay? So I told you to memorize a capital G's constant value lah. Very often you use this value 6.6710 to the power negative 11. Mass all given none. This mass given 5.9710 power 24. And this distance, be careful, you must add up the distance now from the center of the Earth, which is the radius, this value, plus the distance from the surface of the Earth. So this one is in kilometer. Okay, must change to meter, you add 30. Okay. So the total distance is here, the radius plus the distance above the surface of the Earth. So once again, use calculator, very, very careful. You must do it very, very careful, You slightly make a mistake, your answer will be wrong. Okay, so you have to press very, very careful. Okay, so your final answer is this. Okay, 6,450.5 meter per second. This is a orbital speed. Certain books called it linear speed. Certain books say orbital speed. I will use orbital speed because it's a speed to orbit around the planet. Must be orbital speed. A better term will be orbital speed. Okay. Yeah. Okay, can the answer or not? Okay. Question 56 now. Okay, read the question. Calculate the gravitational force. Gravitational force F, okay, between the sphere of mass 1.5 kilo and 0.15 kilo. Okay, we know that between two objects, there will be a gravitational force and pulling force. So, can someone tell me what formula to use here? The gravitational force between two objects, what is the formula? Kelvin, Kelvin Lim, can you hear me or not, Kelvin? Justin, Justin, are you here? Justin, can you hear me?
Yes.
Justin, what formula can you tell me? For question 56, what formula?
F equal to G M1 M2 divided by R squared.
Yes, very good, correct. Okay. F equal to G M1 M2 over R squared. Okay, thank you, Justin. So you see the formula? This is a big G, constant gravity value, constant gravitational constant. M1, M2, mass 1, mass 2 okay? Then R, distance, 4.50 cm, very close. Cm, then you must change to meter. Cm is 10 power negative 2, okay? That's why you times 10 power negative 2. Cm change to meter, so you write times 10 power negative 2, okay? So this is R squared, okay? And finally, use of calculator, you get this answer. 7.4 10 to the power negative 9, okay? Yeah. So be careful, sometimes the unit given to you is different. Sometimes they give you meter, they give you centimeter, okay? So there's a lot of things. Sometimes they don't give you meter, they give you in kilometer, so you have to change. Sometimes they don't give you meter, they give you in centimeter. So once again, you have to change. The conversion of unit is so important, Okay. All right, 57. What is the acceleration due to gravity? This one is find the G gravitational acceleration at a height 3 times the radius of the Earth. 3 times the radius of 3r. Okay. Mass given constant G value given, and the R given. Okay, use what formula to find the gravitational acceleration? What formula here? Let me Chong. Can you tell me what formula to find G gravitational acceleration? The formula is what? Let me Chong. Any idea? Manish, are you there? Manish.
Yes. Yes,
Manish,
sir.
what formula to find?
F equals to GM over R square.
Yes, correct. Not F, is G. Manish, the
Yeah.
formula is G, not F. Maybe you pronounce wrong. Okay. G,
G equals
gravitational
to
acceleration is G. Okay. We say G lah. Don't use F. G. G equal to Gm over R square. Okay. Take G value once again. Memorize this. The mass just put in given by the mass, and this one is the distance is said 3 times the radius, so times 3 now. This is a radius, you times 3. 3 times the radius, then you square the whole thing. Then you get this answer. Okay. So the distance R here is 3 times the radius, 3R. Okay. So you get this. Right? And okay, 58. I think same, not same lah, a little bit different. Okay. A satellite placed in an orbit 6 times 10 power 5 meter above the surface. This is above the surface. Okay, for a place above the surface of the Jupiter. Find the linear speed. Linear speed, you know the formula already, right? What is the formula to find linear speed or orbital speed? What is the formula? Can someone tell me what is the formula to find linear speed or orbital speed?
V equals to square root over R.
Jinghan, can you tell me what formula to find linear speed? RT, are you there? No sound. Gary, there you go. What formula to find linear speed, or we say orbital speed? Gary? No answer, no sound. Ong Chao Xiang. Ong Chao Xiang, please tell me. Ong Chao Xiang. No sound, never mind. We move on. To find the speed, is V equal to square root Gm over R. No, you see the formula? Okay, so you put the value inside, so you get the answer. Capital G value, the mass value put in, and the distance. Okay, the distance here, you must find the total distance, or must include the radius, 7.14, 10 power 7. This is a radius plus the distance above the planet. This is a total distance. So must take the radius plus the distance above the surface, which is 6 times 10 power 5 meter given. So total distance, so you add up. So use a calculator. Do it very, very careful. Get this answer. Okay. You must practice. Once you copy out the answer already, use a calculator, practice. Practice yourself so that you can get this answer. Okay. Use a calculator. Practice it. Yeah. 59. Question 59. Read the question. Yeah, question 59. Calculate the escape velocity. Escape velocity, another formula now. From the Earth for a 5 times 10 power 3 kilogram. This is a mass. After that, determine the kinetic energy. So two things need to be calculated here. Now, one is to find the escape velocity. After that, find the kinetic energy. So they are related one. Okay. So the other value given are these are mass, the G constant value given, and the radius also given. Okay. The formula to find the escape velocity here. Okay. Square root 2gm over r. Got one extra 2 here. If orbital speed line without a 2, you add a 2 here, become escape velocity. Okay. And now do this part first. 2 big G value, the mass, and the R. R given this value, just put in on it. So calculate carefully, you get this answer. This is an escape velocity. Once you know the escape velocity, to find kinetic energy, no problem lah. Half mv squared. Remember kinetic energy formula na half mv squared. Half times mass times square of the speed. This is a formula for kinetic energy. Okay, this formula very important. Kinetic energy formula. So half. This is a mass. This is a speed. Now here, take this value, put here square. Okay, do it carefully. Get this answer. So this is kinetic energy. So the unit is joule. Okay, kinetic energy is joule. And okay, question 60. All right, it's here now. Question 60. Okay, read the question first. A rocket, this is a mass moving from the Earth to the Moon. Okay. Sima, come in again. The mass of the Earth and the mass of the Moon. Okay. So many masses here, you know, these are Earth, these are Moon. What is the gravitational force of the Earth on the rocket? We find the F lah. Okay, so to find the force, gravitational force, right, is F equal to G m1 m2 over r squared. Take G value, m1 mass 1, mass 2. So the two masses just put in now. R is the radius, the distance. Where to get this distance are not given here, right? 1 times 10 power 9 from Earth, right? The distance. From the Earth means that is from the center of the Earth lah. Okay, so do it very careful so you get this value. 9.60 Newton. That force unit is Newton. Okay, 61. The moon takes 27 days to orbit the Earth. 1 month. Okay. Orbit radius is 3 times 10 to the power 8. This is a orbit of the radius, orbital radius lah. The mass of the Earth and the Moon are given. This is mass of the Earth. This is mass of the Moon. Calculate the linear speed. We find the orbital speed. Okay. Once again, this is a formula. Okay. Square root gm over r. G constant value. Mass. Okay. Mass. Now we take the mass of the Earth. You know why? Why take the mass of the Earth? Why we don't take the mass of the Moon? Why? Okay. It's like this. Now, in the case of this question, it's a moon orbiting the Earth. Okay, the moon is orbiting the earth, you know. So now to determine the speed, right, you must take the parent one, so which is earth. So the mass of the earth taken, not the moon. The moon is moving. So the one moving one, the mass are not important one, you know. You must take the main body. The main body is earth, right? The satellite, the moon is orbiting, the moon is moving. So here, important, you know. When you use this formula, right, take the mass of the earth, the main body, okay? And divide by the r of the distance, 3.8 × 10⁸ meter. Okay, calculate. So finally you get this answer, right? So meaning that now here the mass of the moon is here to just to disturb you one, never use one, you know. Okay. So in this formula, remember, you know, take the mass of the earth, okay, the main body lah. Okay, the one moon surrounding, the one moving one, the one to take. Okay. Yeah. Last question. The moon is a natural satellite. The radius of the moon orbit. The radius of the moon orbit is this distance now. Calculate the linear speed. Linear speed means here orbital speed. So use the same formula like just now here lah. Okay. Okay. Same formula. Take G value. Mass, once again, you see now, use a main body, which is the Earth. Divide by the distance. Same answer like just now, 1026, right? And last, the periods of the moon, find the period. Okay, to find the period, this is the formula. 2 pi r over period. Okay, 2 pi r. Beginning of the lesson, I show you this formula, right, to find the speed now. Because you are given the speed. From the speed, you want to find the period. So the formula relating the speed and the period is this formula. Now got the speed here, got the period. So use this formula lah. Okay. So I bring the period up here, the speed bring down. So 2 pi r. R is the radius, the orbital radius. Okay. Divide by the speed. T up already, this V go down. Okay. So calculate, you get this answer. It's 27 days lah. The period is 27. Once again, when you calculate here, right, you don't get this answer straight away, you know. You get the answer in second. So second change to day, remember. Then you must change second to day. Divide 3,600, divide 24, okay? Remember. 1 day, 24 hours. 1 hour, 60 minutes. 60 minutes, 1 minute, 60 seconds, okay? So divide 3,600 and once again divide by 24. Then you get the days, okay? Right, this is the last question, okay? So you copy down all the answer lah. You have to repeat many times, you know. Read the question, see how to get the answer. So you have to read many times, you know, okay, for your revision now. This chapter usually the question they ask you, most of the question they ask is calculation. It's very important in calculation. Okay. There are 2 new chapters in the new syllabus, you know, Form 4. You are the first batch of this new syllabus now. Okay. So Form 4, you got 1 new chapter. So this chapter 3 lah, gravitational. Then when you go to Form 5, there will be another new chapter. Okay. There one even more calculation, a lot of calculation. The 2 new topic put in 1 topic in Form 4, 1 topic in Form 5 are mini calculation. Okay, a lot of calculation one. Okay. Yeah. Okay, so we have finished this already. So anyone got any question to ask here? Anyone here got anything to ask or not? Juling, any question to ask? Juling?
No, sir.
No question. You have finished all already lah. Oh. Yishin, Lao Yishin, any question to ask? Lao Yishin ah. Hong Chao Xiang, anything to ask?
No, sir.
No, all no question one. You're very passive lah. I think one day lah, we ask you all to on your video, you know. You cannot hide behind, you know. You are hiding behind lah. If like this lah, I tell you now lah, if after June now, you still cannot go back to school, cannot go for tuition, right? The school not open means tuition also cannot, you cannot go one, you know, because tuition also you sit in a room, so the government wouldn't allow one. If after June still carry on online teaching like this, so I will ask you all to register with the email. So I will send the password, everything through the email to you. So you must use an email to log in. Not like now, you know, everybody also can come in one. Okay. So I will ask your email address later on. After June, still like this, cannot go to tuition, cannot go to school, right? And then I will ask everyone to turn on your video. Switch off your microphone. Your video have to be on. I want to see your face. Not like now, you know. Now you are hiding behind. I don't know whether you are there or you are listening or you are doing something else. I don't know. Okay, after June, still carry on like this. Everyone must on your video. I want to see your face, man, you know, so that I can call your name straight away. When I call you, then only you on your microphone. If I don't call you, you just show the face only. Microphone you off. Okay. Understand now? Commonly, do you understand me? Common.
Yeah.
Understand or not? Understand? McNish, do you understand?
Yes, sir.
Okay. All right. So chapter 3, the revision we have done, finished already, right? So we have to go back to chapter 4. Okay, chapter 4. You guys still remember what is chapter 4 or not? Kanwan Yu, Kanwan Yu, are you there? Kanwan Yu? Sawan, call not there means are not in already. Pritiba, are you there?
Yes, sir.
Pritiba is a good girl. Sure, she will be around one. Pritiba, chapter 4, what is the title of chapter 4? Can you tell me? Chapter 4 title is what? Pritiba? Answer.
Heat, sir.
Heat, one word only. Heat, right? You already finished 3 lessons, you know. I just test you all the lesson 1, lesson 2, lesson 3. I test you the title only, not the content. Okay? Xiao Wei Zhen, are you there? Xiao Wei Zhen? Xiao Wei Zhen. No sound. Ong Chao Xiang, are you there? Ong Chao Xiang.
Yes, sir.
Lesson 1, what is the title of lesson 1 of chapter 4? Start with the E. What is the title of the lesson? Lesson 1, chapter 4.
Lesson.
Start with Therma what? Therma equal
Equilibrium.
therma equilibrium. Your lesson 1 is therma equilibrium. And your lesson 2 is what? 进一ห้อง啊 进一ห้อง are you there? ชิงฮัน are you there? ชิงฮัน Jia Wei, Yong Jia Wei,
Yes, sir.
Yong Jia Wei, lesson 2 what is the title? Lesson 2. Lesson
Specific
1
heat
is
capacity.
thermal equilibrium. Lesson 2.
Specific heat capacity.
Yes, very good. Your lesson 2 is specific heat capacity. Remember the formula Q equal to mc theta, right? Not specific heat capacity. Q equal to mc theta. Then your lesson 3. Lesson 3 is what? What title? Lesson 3. Zizhen, are you there? Wasiumei, are you there?
Yes.
Lesson 3. What is the title?
Specific latent heat.
Yes, very good. Okay. Specific latent heat, right? So the formula is Q equal to ml. So 3 lessons you already covered enough. Okay. If you forgotten already, never mind, you can go back, read your notes again, right? You have the notes, right? You don't have the notes, so you go to the YouTube and see lah. Okay. In your WhatsApp group, they also got the link, right? You just click the link and see the video. Okay, for tonight, we are going to lesson 4. Okay, lesson 4, the last lesson of chapter 4. Okay, now I believe you have this paper, right? Everyone, lesson 4. This paper you have or not? Gas law. Everyone got, I asked myself only because I did not share it. Okay, so I had to share it first. This lesson, okay? Go slowly lah, gas law, okay? And this lesson, gas law, right? You are going to study formula. Once again, is formula calculation. Gas law is very important for calculation now, okay? So when you look at here first, straight we look at here. Don't panic. Okay, slowly we go very, very slow. Okay. Now these are the main ingredient main thing you are going to study in lesson 4. Okay. So the 3 gas law you're going to study. The first one is Boyle's law. Boyle. The scientist's name is Boyle. The second one is Charles law. The third gas law is pressure law. So remember the name first. Boyle, Charles, and pressure law. 3 law you're going to study. Law, definitely formula, right? Boyle's law formula is this one. P1 V1 equal P2 V2. Pressure, volume, pressure, volume. So meaning that Boyle's law is study on pressure and volume of gas. Pressure of the gas and volume of the gas. 1 and 2 means first situation, second situation. So this is a Boyle's law formula, right? Don't worry, we just go through the surface first. Later on, we go into detail. Okay, the second one is Charles law. Charles law, you see the formula, is study the volume and temperature. T is temperature. So you see V1, T1, V2, T2. Volume, temperature, volume, temperature. Okay, so Charles law. So you can see already now. Boyle's law study pressure and volume. Child's law study volume and temperature. This temperature is not normal temperature, not the degree Celsius, it's absolute temperature. Absolute temperature means this temperature is in Kelvin. Kelvin 1 cannot be in degree Celsius. Change to Kelvin. And the last one is pressure law. Pressure law study pressure and temperature. Pressure, temperature, pressure, temperature. Okay? Yeah? Okay, now I give you 2 minutes. Everyone, you got to memorize and name the formula, name the formula, name the formula. Okay, memorize it now. Now, 2 minutes time later, I call your name so you answer. Okay, get ready now. Okay, time's up. So now I call your name so you answer. Don't try to dissipate yourself. Okay. First one, okay, I call who? Chua Michelle. Chua Michelle, are you there?
Yes, sir.
Chua Michelle, can you name the 3 gas law?
Ball, Charles, pressure.
Yeah. Yes, correct. Boyle's law, Charles' law, and pressure law, the 3 names. Okay, second question will be a bit difficult one. Okay, second question I want to ask you all. When you study the 3 gas law, right? They are involving 3 things. What are the 3 things? Can you tell me? When you combine Boyle's law, Charles' law, and pressure law, right? So you realize that the 3 gas law actually they are focusing on 3 aspects. So what are the 3 aspects? 3 things you can look at the formula, you know already. Okay, Ballet, they have only these 3 things only. What are the 3 things you study in the gas law? Confusion, can you answer or not? Confusion? What are the 3 things? When you look at the formula of Boyle's law, Charles' law, and pressure law, right? You realize they're only going around 3 things only. What are the 3 things? Confusion, you want to answer me? Hashini, are you there?
Yes, sir.
Hashini, can you tell me?
Pressure, volume, time.
Once again, what is that?
Pressure, volume, time.
Time. Did I say time just now? Yes, you answer correctly. 2 out of 3. Another student. Okay, I want to ask Yong Jiawei. Yong Jiawei, what are the 3
Yes,
things? Just now, Hashini answered correctly 2 already. One more is what?
Temperature.
Yes, temperature. So you can see the formula, right? Actually, now, when you study the gas law, like Boyle's law, Charles' law, pressure law, right? They only focus on these 3 things, right? Pressure, volume, and one more is temperature. The T is temperature, not the time, Hashini. Hashini? T is temperature, right? Okay, so roughly now, you know what is gas law already, right? The next question. Juling,
Yes, sir.
can you tell me what is the formula for Boyle's law?
PV equals to PV.
PV equal to PV. You miss something there.
P1 V1 equals to P2 V2.
Yes, correct. You must differentiate them 1 and 2, different situation now. P1 V1 equal P2 V2. This is Boyle's law formula, right? Okay, next. Next is Kelvin Lim. Are you there? Kelvin?
Yes, sir.
Kelvin, what happened to you today? I saw you log in many times, only can come in, or why? Cannot come in?
Not sure, sir. I tried a lot of times, then suddenly cannot come in. Every time I keep waiting inside the waiting room.
No, never mind. Next time you cannot, your modem, you got to restart your modem, your house modem, understand?
Okay, sir.
Not here, no. I allow you to come in many times. I see by your name still turning there. Okay. Next time, you got to restart
Okay,
your
sir.
modem. Just restart
Okay.
the modem. Kelvin, Charles' law formula
thank
is
you,
what?
sir. Charles' law formula is V1 over T1 equals V2 over T2.
Yes, very good. V1 over T1 equal V2 over T2. Thank you, Kelvin. And last one is Sima. Sima, are you there?
Yes, sir.
Can you tell me the formula for Pressure's law?
P1 over T1 equals to P2 over T2.
Yes, very good. P1 over T1 equal P2 over T2. Okay, pressure laws formula. Okay, now we look at the paper. Okay, we have to start from the beginning, okay? We have to learn a little bit theory first, gas law. That is why I told you here, okay, please jot it down. In gas law, we focus on pressure, temperature, and volume, okay? The main things are we are focusing on these 3 only when you study gas law. Okay, pressure, temperature, and volume of the gas. Gas pressure, temperature, and volume in terms of gas molecule. Okay. Kinetic theory of gases. Please highlight the words kinetic theory. When you see kinetic theory, means I'm talking about the molecule, how the molecule move. So to explain the gas law, the basic assumption means in order to study the gas law, we have to assume this kind of thing. We have to make assumption, we have to assume the gas molecules are too small, no mass like that. Okay. So when you look at this diagram, the gas molecule are so many gas molecules here, right? Actually, they are moving around non-stop, randomly, in all directions they are moving. So what are the assumptions we make? So what is the assumption you must know, Highlight first one. All gases make up a very large number of tiny molecules. Okay. First assumption is all gas make out of tiny molecules. Very simple. Number 2, these molecules are constantly moving around randomly at high speed. Second assumption, we have to assume the gas molecule actually they are moving non-stop randomly. Okay, day, night, hot, cold, they are non-stop moving. They won't stop one. Understand? Third assumption, the molecule collide elastically. Elastic collision. Do you remember or not? That means the molecule that collide, they bounce back. Once they collide, they bounce back elastically lah. Okay, collide elastically with anything that meet. If they hit the inner wall of the container, they bounce off. Okay, so meaning that you see here like this is a container, right? When a gas molecule hit the container, right, the wall of the container, so we get bounce back lah. See like this one hit here, so he will get bounce back. Terbalik. Okay, hit here then bounces back lah. Okay, like that All right. Number 4, the molecules are so small and so far apart, they almost never collide with each other. This is what they assume lah. We assume all the molecules never collide with each other. Seldom collide with each other lah. Then the volume of gas molecule themselves is negligible. Meaning that we assume gas molecule has no volume. They're too small. So no volume our assumption. Remember gas molecule has no volume. Negligible means we assume no volume lah. With the volume of the container. Almost all the gas is empty because empty one. The gas molecule here no volume one. So we assume inside actually empty. Right? Okay, number 5. They do not exert any force on each other, but move randomly. This is an assumption for your essay writing. You must know, all the gas molecules that do not exert any force on each other, but they move randomly. There's no intermolecular attractive force. See, in the form of gas, between the molecule, there's no more binding force, no more attraction force. Okay. Intermolecular forces of repulsion act only during collision. No attraction force, but there will be a little bit of repulsive force when they collide. Okay, only when they collide. Intermolecular force of repulsion act only during the collision between the molecule. The duration of collision is negligible. Means time of collision is too short, so we can assume 0 lah, the time. Okay. Okay. How the gas pressure is produced. This one I want you to tell me. I don't want to tell you the answer. Okay. My question is here, when you capture gas inside a container, let's say this is a container, right? You capture the gas inside. Okay, I want to let you know the gas pressure only occur when you capture it inside a container. When you don't capture the gas in a container, there's no gas pressure one, For example, surrounding you, surrounding us here got a lot of air are gas, isn't it? So we assume no pressure from the gas one, unless you put the gas inside a container like this. Okay, so remember, gas pressure only occur when they are captured by a container. You put them in a container, then only you see got gas pressure. Okay. Class, can you read from here the whole paragraph? Then later on, I want you to tell me how the gas pressure occur, how the gas pressure come out. Okay, 2 minutes. You read your study here. Study. Then later you tell me. Okay. Now, agak-agak you tell me lah. Okay. Hashini, are you there lah?
Yes, sir.
Hashini, can you agak-agak tell me how this gas pressure occur? Agak-agak lah. See whether you know or not. Wrong also never mind. Agak-agak lah. How this gas pressure occur one?
Collision occur between the molecules and walls of container.
Yes, very smart fellow. That's why I say Hashini is very smart. Okay. What's her answer is exactly what I want. Actually, now the gas pressure occur only when you look at this diagram. There will be only gas pressure when this molecule hit the wall of the container. When you hit the wall of the container, it bounces back. When you hit the wall, so it produces pressure. So remember, very simple. So remember, gas pressure occur is because the gas molecule hit the wall of the container. They must have a container, no gas pressure one. So the moment the molecule hit the wall, keep on hit, non-stop hitting one, When you hit the wall of the container, so it turns into pressure. That is how the pressure comes. Okay. I want to ask you one more question. They collide with the wall, produce pressure, correct not? What about the collide among themselves? The gas molecule collide with the gas molecule. This one can produce pressure or not? Yuling, do you know my question or not?
I think can. Not sure.
You think can? Okay, no. The answer is no. Okay, listen. Actually, there are two types of collision, Listen, let me explain in your mind. Molecule and molecule can collide each other. It can happen. But the collision between this molecule and this molecule, it doesn't produce pressure one, no pressure one. When they collide themselves, no pressure. Remember that, The pressure only comes when they collide with the wall of the container only. So remember, So very tricky question, They ask you, molecule and molecule collide themselves, got pressure or not? Remember, no pressure. The pressure only comes when the molecule hit the wall of the container. Understand? So remember what I told you, Okay, now we look at the explanation here, Based on the assumption of kinetic theory of gases, molecule of gas will occupy entire available space and collision occur between the molecule and the walls of the container. This is very important. Collision between the molecules and the wall of container. Now collide with the wall of the container happen. Imagine a molecule of mass, never mind. When you collide with the wall, right? So you have momentum law. Momentum is mv. You all remember, right? Momentum, mass multiplied velocity, mv. Okay, it bounces back. Rebounds back with velocity negative. So it becomes negative mv. So when go here is mv, momentum. When bounces back, become negative mv, correct not? So this is momentum to the right. This one is when it bounces back, right? So it's momentum to the right. Now, change in momentum, change in momentum means you take this one minus this lah. To find change in momentum, you just minus only. You either take this one minus this, you get negative, doesn't matter. Or you take this one minus this, you get 2 mv. Right? You minus, mv minus negative become plus, isn't it? So it's 2 mv, right? Okay. According to Newton's second law, okay, Carry on here now. What do you say? Force is exerted on the wall because force is the rate of change of momentum. Because change in momentum divided by time, so it becomes force, impulsive force. Do you remember or not? Impulsive force, change in momentum. MV minus MU just now, change in momentum, right? Final momentum minus initial momentum is change in momentum divided by the time. You get impulsive force. Then after that, force divided by surface area. When I hit the wall, so hit on the surface area, isn't it? Force acted on surface area, so it becomes pressure. That is how the pressure comes. Change in momentum over time. When you hit the wall, bounces back, or change in momentum happen in a short time, isn't it? Then you have force, impulsive force. When this impulsive force act on the surface area, when you hit the wall or container of surface, right? So it becomes pressure, because pressure is force over area. Understand? As a result, gas pressure produced, because definition of pressure is force per unit area. This is how finally the pressure comes, So remember, the pressure comes from change in momentum. When a molecule hit the wall, bounces back, change in momentum happen. Then change in momentum divided by time, so become a force, impulsive force, right? Then this force act on the surface area, force per unit surface area when you hit the wall, right? With surface area. Then finally, it become a pressure. That's how the pressure comes, Okay, And the gas pressure container is a total force produced by collision between the molecule and the wall. Not here, like important, Pressure is produced by collision between the molecules and the walls of the container. The higher the average kinetic, the faster the molecule move, the greater the pressure. Okay? But here they must understand, we say the higher the average velocity of the molecule, the greater the pressure. Now the big question is how to make the gas molecule move faster. When a gas molecule moves faster, the pressure becomes bigger. How to make it move faster? Now, you look at here. You heat it up. What happens when a gas is heat up? When you heat up the gas, here the gas moves slowly. When you heat up the gas got more energy already. So the gas will move faster. Okay? It will move faster. When you heat up the gas moves faster. When gas moves faster, when you hit the wall or the container more often, so pressure becomes higher. Very easy to explain. Okay, can you read from here? As a gas is heated, the molecule moves faster. All this explanation you must know how to write, Okay, when you heat up the gas, the molecule moves faster because kinetic energy of gas proportional to the temperature. The higher the temperature, the more kinetic energy the gas got, isn't it? As a result, pressure of the gas increases if the volume of gas is fixed. For example, like this, this container cannot be expanded fixed volume. So when you heat up the gas moves faster. So you heat the wall or container more often, automatically the pressure becomes higher. Okay, when this container volume cannot expand, it's fixed, Okay, but when this volume can change, let's say this container can expand, it's different. Later on you see. Therefore, a fixed mass of gas in a container has three characteristics: highlight pressure, volume, temperature. Okay, so we only focus on these three, pressure, volume, and temperature, but must be fixed mass, The mass of the gas, the amount of gas must be remains the same. The mass of the gas. Okay, the mass of the gas remains the same means the container you don't change. You don't change the container means the mass of the gas remains the same. Okay, all right. And finally we have this. Okay, all these three formula come from here. Can you jot down this one also? Actually, This one is combining the three laws. The formula is P1 V1 over T1 equal P2 V2 over T2. This one also can be a formula, you know. This is we call it universal law of gas. Universal means you cover everything already. Boyle's law, Charles' law, pressure law cover everything here, so become universal law. Okay, P1 V1 over T1 equal P2 V2 over T2. This formula actually from here lah. P1 V1 equal P2 V2. Boyle's law come from here. You see or not? This formula. Okay, come from here now. Boyle's law. Charles' law you take here. I think I circle for you lah. When you do like this, right? This is Boyle's law. Not this formula, Boyle's law. Okay. Charles' law you take here. VT like this. This is Charles' law. Okay. I hope you all can see that. V over T, Charles' law. Okay. And the third one is pressure law. Pressure law, you take pressure T from here. Law. Okay. Third one is here. There are three, you know. First one is horizontal. Charles' law is here. Pressure law is this one. Okay. So they combine three lah. Yeah. Okay, remember, no Boyle's law. But when you write the name of the law, you don't like B-O-Y-L-E, no. Boyle's astrophy S. You have to put like this one, you know. Okay, Boyle's law. Okay, Boyle's law. Charles' law. If here is already got like S, right? You don't need to just put comma here. Charles' law. Okay. Pressure's law. Okay, remember now. So tonight I think we study until here lah. Roughly you know the formula, Boyle's law, Charles' law, Pressure's law. You know the formula P1 V1, P2 V2. This is Boyle's law. Charles' law formula is V1 over T1 equal V2 over T2. Pressure law is P1 over T1, P2 over T2. That's enough lah. The next lesson, next week, we only go into more detail on this lah. Okay, 10 o'clock already, so I have to stop here lah. Yeah. So anyone want to ask any question here? Any question from you or not? Mei Hui, anything to ask or not? Yi Mei Hui, anything to ask or not? Clement, got anything to ask? Jen Leong, anything to ask?
No.
No, Okay, if no, so I want to say thank you to everyone, okay, to follow this lesson until now. Okay, I hope to see you again next week. Okay, next week we have to have 2 lessons again, you know, which is Monday, Wednesday lah. Okay, but my lesson will be short. Won't be so long one. So with 10 o'clock I will stop. Okay, if 10 o'clock I don't stop, you tell me to stop. Yeah. Okay. So once again, thank you, and please take good care of yourself. And remember, study. Okay. Your tuition teacher asks you to do what? Asks you to study, so you follow. The school teacher asks you to study, wants you to do, so please follow lah. Okay. So always remind yourself, you know, this is not school holiday lah. This is normal schooling day, you know. The only thing is you cannot go to school. But you don't stop study. You don't go to school doesn't mean you can stop study, you know. No, you have to continue to study. Understand? Time will not wait for us. So we have to carry on your study process. Understand? Okay. I think that's all. Good night, everyone. Bye-bye.
Thank you, sir.
Okay, bye-bye.
Bye.
Bye-bye.
Thank you, sir.
Thank you, sir.
Bye.
Thank you, sir.
Okay, bye-bye. Bye-bye.
Bye-bye.
Yes, bye-bye. Ya, bye-bye ya.